Hey, it's Courtney Tampone. So I'm doing Chapter 3, The Nuts and Bolts of Classical Conditioning, and I'm Section 4, pages 101 through 109. So we're going to start on information value in conditioning. So during the 1960s, it was discovered that conditioning does not only automatically happen when a controlled stimulus and uncontrolled stimulus are paired, but when the controlled stimulus provides information about the upcoming uncontrolled stimulus. And Robert Rescorla studied this in a demonstration that included 3 groups. So group 1 included positive contingency, which is the probability of the uncontrolled stimulus being greater than when the controlled stimulus is other than when the controlled stimulus is off. Then we have group 2, zero contingency, which is the probability of the uncontrolled stimulus is the same whether the controlled stimulus is on or off. And then we have group 3, negative contingency, which is the probability of the uncontrolled stimulus when it is less than controlled stimulus or when the controlled stimulus is off. This results in a decrease in the likelihood of the uncontrolled stimulus. So the results of this were group 2, the one of zero contingency, acted like there was no association between CS and US, showing that the pairings of the two were not sufficient enough to produce conditioning. So here I define it. Positive contingency is the uncontrolled stimulus is more probable when the CS is on than off. Negative, the uncontrolled stimulation is more probable when the uncontrolled stimulus, when the controlled stimulus is on than when it's off. An example of that is inhibition. Uncontrolled stimulus is equally probable when the controlled stimulus is on and when it's off. And there's no contingency between the uncontrolled stimulus and the controlled stimulus. So lack of contingency is 0 points. So if there's no contingency, there is no conditioning. So we also have blocking and unblocking. So Leo Kamen was the one who performed experiments to develop this theory, and he did this with rats in controlled suppression, and he did this in 3 phases. So in phase 1, he projected a noise, which was the controlled stimulus, he presented a noise, which is a controlled stimulus, with a foot shock, the uncontrolled stimulus, and that gave a strong response. Then in phase 2, he presented light and noise combined with the shock, and the shock was, again, the uncontrolled stimulus. And the noise had not been conditioned from the subjects from phase 1. In phase 3, only light was presented. So the results of this was that the groups that received the light combined with the noise that had previously been conditioned showed no evidence of learning. So that's the blocking effect. If something was previously conditioned, it's going to block the new conditioning. We can apply that in education as well. If you learned something a long time ago and you try to learn something else on top of it, sometimes you have a hard time learning the new way to do something or the new information. So then we have the blocking effect. So it suggests that conditioning does not simply happen just because the controlled stimulus and uncontrolled stimulus are paired. There has to be a good matching between them, or else there's not going to be any conditioning or learning. So learning only occurs when the controlled stimulus, again, provides new information about the uncontrolled stimulus. So the noise here in this example is blocking conditioning to the light. So here again, look at another conclusion of Kamen's findings. So then we have overshadowing. So a definition of this is the idea that compound cues that they compete. So 2 controlled stimuli can be presented together in compound and paired with the uncontrolled stimulus together. If one controlled stimulus is stronger, or we can call that more salient than the other, it'll prevent good conditioning of the other controlled stimulus. So the one with higher saliency overshadows the other. So an example that this was can be shown in real life practice, like clinical practice, that could be chemotherapy. So what they do with that is taste aversion. So nausea and vomiting is a common symptom that a patient experiences when undergoing radiation. So a nurse or health care provider could administer a hard candy or something like that before the beginning of therapy, so the patient relates the symptom of sickness, feeling of nausea after therapy, to the candy, not the food that they just ate before coming there. So the candy acts as the scapegoat. So then we go on to Alan Wegner in relative validity. So he studied around the same time as Common, but he did a little bit of separate research. So what he did, he provided two groups, and both groups had a controlled stimulus occurring in every trial, and half the time it was simultaneously presented with a stimulus, and then the other half a separate stimulus. So he provided the two groups. They're called group correlated and group uncorrelated. So in group correlated, the stimulus A and the controlled stimulus X were always paired with the uncontrolled stimulus. The results of that were, as you can see, with the abbreviation AX, results in is paired with US, and then BX, there is no US. And then with the group uncorrelated, the stimulus A and B were put together half the time and paired with the uncontrolled stimulus. So here we have AX, which is stimulus, and the controlled stimulus was paired with uncontrolled stimulus half the time, and BX, the different stimulus, correlated with the uncontrolled stimulus for the other half of the time, and the results were AX to UX, then AX to no US, BX to US, and BX to no US. So you can also, so the results of that were more conditioning is in the group uncorrelated. So then we have another real-life application. So it can be compared with the cravings of drugs and addicts, which is a little bit more easier to explain than just the abbreviations. So how we could think about this is, like, let's say we have two stimuli, odor in a room, and that correlates to a drug. So you present the odor in the room, the person will have a craving for the drug. If you present the odor in a room again, the drug. If you present a friend in a room, they're not going to want to do the drug. Again, if you want to present a friend with a room, then you don't want to have the drug. Then again, for another person, on the odor of the room, you want the drug. The odor in the room, you might not want the drug. This is in the group uncorrelated. Then the friend comes in the room, and you want the drug. And the friend doesn't, the friend comes into the room, and you don't want the drug. So for group B, uncorrelated, there isn't any correlation between the two stimuli, because you have two different outcomes every time every time you present the two. With correlated, you would have the same effect every time. So if you present the odor in the room, every time, the person's going to crave the drug. And that is not the case in uncorrelated. And that makes it a little bit easier to explain. But, yep, so that's a little bit about relative validity in Chapter 3, the nuts and bolts of classical conditioning. I hope you enjoyed, and I hope you have a good day.